Once again, welcome everyone to Sale Martha's Vineyard's Winter Lecture Series. Some of you may have been here last year. Tonight we have Brian Whitley with Weather Routing Inc. Talking about nor'easters, which here on the Vineyard we know and love very well. Just a couple of things I'd like to remind everyone to please keep your mics muted if possible during the event. If not, I'll have to mute you at times if we hear too much noise. And also please use the chat box if you have a question. At the end of the talk, Brian is kind enough to answer a few questions. We would also like to just let you know that this talk is being recorded, and the questions and answers will be recorded as well. And on the Sale Martha's Vineyard main website under events, there's a section for winter lectures, and you can see some of the events there that have been previously recorded, and they're quite interesting, including Brian's talk last year on weather basics, which was fascinating. So check it out after this talk. Couple of things that we love you to join us with in the future are coming up this summer. We're really happy to be back in person doing live events on the Vineyard. And of course, on July 7th, we'll have the 31st annual seafood buffet and auction. And on July 9th through the 10th, the weekend, we'll have the Vineyard Cup Regatta. And thanks to Weather Routing Inc. For many years now, they have provided us with custom detailed weather reports for the Vineyard Cup Regatta, which are really fantastic and make it so wonderful for the competitors and for us managing the race to know exactly what to expect and exactly what's going to go on out there on the water. Really shows you what weather routing can do. So I'm not going to rattle on any longer. Let me turn it over to Brian.
All right, thanks so much, John. First of all, I just want to confirm, can everybody see the presentation here before I get started on it? Perfect. Okay, well, I'll get started. First, I'm going to introduce myself. I am Brian Whitley. I'm an operations manager at Weather Routing, but a little bit of my backstory. I actually grew up in the Boston area on the South Shore, growing up in Quincy and Canton, Massachusetts. So nor'easters have a very special place in my heart. A lot of people like to joke with us when they're calling in saying, you know, they wish that we not only forecast the weather, but that we actually control the weather. And I like to remind them at that point that it's not blue skies and sunshine that got me into this business in the first place. It's the hurricanes and the nor'easters. I have very distinct memories of the blizzard of '78 and the April Fool's snowstorm. That's the sort of weather that got me into meteorology. So I'm the last person in the world that you want to have that power. All right, let's move on here with the presentation. And talk a little bit first about the company that I work for. As John mentioned, we are Weather Routing. We've been in business for quite a few years now. The company was actually started by a meteorologist who initially was a forecaster during World War II, founded the company back in 1961. We do provide custom tailored forecasting and routing for maritime interests, not just sailing vessels and yachts, but also commercial vessels, sport fishers, cruise lines. Cruise lines not as much these days for obvious reasons, but hopefully that will be picking up here in short order. As far as what we're going to be talking about, we're going to start off first with a general discussion about what a nor'easter is. We'll talk about what the ingredients for a nor'easter are. We'll look at the development of nor'easters, how they develop, and then we'll take a look back at recent history. The blizzard of 22, I don't know if there is an actual official name for it yet, like the superstorm or anything like that, but I'm calling it the blizzard of 22 that just happened back in January. We'll take a look at how that system evolved. So first of all, the definition of a nor'easter. What is a nor'easter? Well, honestly, there really isn't a set meteorological definition for a nor'easter, but in general terms, of course, it is a strong storm, or at least a strong low gale storm that develops along the east coast of the US, generally within 100 miles or so of the coast, either inshore or offshore of the east coast from Georgia up through Maine. And the reason they're called nor'easters isn't the direction that they move, it's that the strongest winds with a nor'easter are from the northeast. And we certainly saw that with the last storm. As far as the ingredients for a nor'easter, the jet stream plays a huge role just in the development of weather systems in general, of course, but also a particularly large role with the development of strong storms, including nor'easters, strong extratropical storms, I should say. The jet stream does not have significant roles in tropical cyclone development. But with the jet stream, basically, it's, of course, a column of very fast moving air at the upper levels of the atmosphere that tends to separate warm air to the south from cooler air to the north in the northern hemisphere. What happens with the jet stream is it can change its elevation within the atmosphere. And in warmer environments, the jet stream tends to gain elevation. In colder air masses, the jet stream tends to produce downward motion. Now, if you can imagine the upward motion in the atmosphere on the east side of this map, that upward motion in the atmosphere kind of acts like a vacuum in that it's removing air from the lower levels of the atmosphere. Conversely, on the western part of this, out near Texas and the Rockies, you've got downward motion in the atmosphere, or compression that's taking place. And those two motions in the atmosphere vertically, the upward motion creating that vacuum near the surface, you've got lower pressure as a result of that upward motion. Conversely, to the west, downward motion, that compression creates higher pressure and high pressure systems at the surface. Now, I mentioned previously that the jet stream tends to love areas of significant temperature discrepancies or differences, perhaps a better word. And the Gulf Stream can play a significant role in helping to strengthen the jet stream. This is actually an image off of Weather Routing's website, seaweather.net. It's a subscription service that we offer. But this is sea surface temperatures of basically the mid-Atlantic up through New England, and pretty easy to pick out where the Gulf Stream is, rather. Temperatures in the mid to, in some point, places there off South Carolina and Georgia, upper 70s. To off Cape Hatteras, and then turning east-northeastward, well out to sea, of course, well south of New England. But that temperature gradient can provide added oomph, if you will, in terms of strengthening the jet stream, in particular, if you've got a significantly cold air mass across the interior, across the Carolinas and points westward through the Ohio Valley. Of course, with the Gulf Stream, you also get the added benefit with those warm waters of quite a bit of moisture. And of course, nor'easters tend to feed off of moisture from farther south as well, the Gulf of Mexico and the Caribbean Sea. Let's talk a little bit about the development of nor'easters and low pressure systems just in general. This is the next several slides here. We're going to kind of go over the Norwegian cyclone model. It was actually developed by Norwegian meteorologists to basically explain how low pressure systems develop. Now, in the initial condition, you've got a boundary, a front, and in this case, it's a stationary front. There's no low pressure area along it. To the north and west of that boundary, you've got cold air mass. To the south and east of that boundary, you've got a warm and likely humid air mass, or at least humid with respect to the other air mass. As we move along, in the beginning stage of that, you get a disturbance. So a little weak low pressure area may start to develop along that stationary boundary. Now, the air around a low pressure system flows counterclockwise, cyclonically, so that warm air that's on the south and east side of the system starts to move north. The cold air that's on the north and west side of that system begins to move south and southeastward. At the next phase of the Norwegian cyclone model, that low pressure system, in perhaps a nor'easter, developing nor'easter off the east coast, the intensification phase. That low is rapidly developing in the case of a nor'easter. That warm air on the south and east side of the low pressure area is riding up and over the colder air to its north. That upward motion in the atmosphere, lifting up that warm, humid air over the colder air mass. That warm, humid air cools as it goes up through the atmosphere. It condenses, forming clouds and eventually precipitation. Moving on to the mature stage, in this case, potentially a strong nor'easter, the low pressure system at the surface is at its strongest. But notice on the diagram to the left that you've got the blue line indicating a cold front, the red line indicating a warm front. But where those two converge, you're starting to get an occluded front that's indicated by that purple line. Basically, the cold front is catching up to the warm front, and thereafter, what's going to happen as we move to the dissipation stage, that warmer air is now no longer really getting to that low pressure area. The low is getting cut off from the source of its intensification. So thereafter, and this tends to be a weaker process, but the low tends to more slowly dissipate as we go through time here. And that cold front will just continue to catch up to the warm front. The cold fronts generally move faster than warm fronts. Now, there's two different types of nor'easters. These were generated by a gentleman named Miller. I believe this was back in the 30s, who came up with this system. There's two types of nor'easters. The Miller type A is sometimes referred to as the classic nor'easter. You often have a stationary front or a marine boundary stalled off the coast of the Carolinas down to Florida. Lots of warm, humid air south and east of that, and a very cold air mass farther north and west, and a strong high pressure area across New York State and northern New England. And with these systems, the low pressure areas develop off the Carolinas and then move northeastward. And these tend to be the big ones, if you will. And that storm that we had back in January, that was a type A type of nor'easter. And again, we'll talk more about that storm here in just a little bit. The second type of nor'easter is the Miller type B. In that case, these also can be strong storms, but what happens is the storm actually comes in more from the west initially rather than from the southeastern US. Comes east-southeastward through the Ohio Valley or perhaps across the Great Lakes. And then what happens is as it reaches the Appalachians, a new low pressure area, a secondary low, will often redevelop along the mid-Atlantic, and that will then intensify more significantly before it turns northeastward. These systems can also, of course, bring very significant snow and wind, of course, to the mid-Atlantic and the Northeast, but they tend to be not quite as strong as the type A's. Not nor'easters, but a third type that I did want to kind of also mention here is the Alberta Clipper system. These tend to not bring quite as much in the way of wind and snow because they're often cut off from the higher moisture content air masses farther to the south. So these systems tend to move very quickly. They move out of Alberta, Canada, and then they move southeastward. They can pick up a little bit of moisture from the Great Lakes, but again, they tend to be somewhat moisture starved. They can redevelop and strengthen when they move offshore, but typically they're moving so quickly at that point that even southeastern Massachusetts tends to get just the very quick touch, if you will, of that system as it strengthens while moving offshore. All right, so let's talk a little bit about that storm that that you guys got to experience a little over, well, it was actually less than a month ago at this point, I suppose. But here's a view, an animation of the jet stream as it evolved over the 24 hours prior to the system and then up through the system. It's a little bit, of course, difficult to interpret here, but there are extremely strong winds at the jet stream level in excess of 130, 130 knots here, I believe at one point I saw. And I'm going to move forward here, and I did some less than professional drawing here of what's going on, but there's two jet streams that are in, or that were involved, and this is often the case here, but the polar jet stream, as the name implies, originates closer to the poles, and you can see that pretty significant dip as the jet dives southeastward toward the southeastern US before turning back to the north and east. Also, there's the subtropical jet stream that originates across the Baja Peninsula, moves across northern Mexico, and then kind of joins up with the polar jet stream across the southeastern US. What I want to kind of point out to you here, and hopefully you can see that with the mouse, is as those jet streams combine and then kind of separate a little bit, you're getting what we refer to as divergence. That's the air at the jet stream level, while moving very strong, of course, moving very fast, is also moving apart. And that creates divergence at the upper levels of the atmosphere and further increases that vacuum, so to speak. So all the air that's getting evacuated at the upper levels of the atmosphere has to be replaced by air coming up from down below. And that creates that low pressure area at the surface, strengthening that low and ultimately strengthening the system itself. Here's an animation of NOAA's surface analysis of that particular system. And again, this was a Miller type A nor'easter. You've got at the start of this animation a stationary boundary located basically from northern Florida off the coast of the Carolinas, more or less right along the Gulf Stream. And as an upper level disturbance moves southeastward through that polar jet stream, it works in tandem with that subtropical jet stream to help develop that low pressure area basically off the coast of North Carolina that then moves north, basically due northward just to the east of Cape Cod and ultimately toward Cape Sable, Nova Scotia. Moving on here, I did want to show this is actually about the height of that particular storm. And the low pressure area, the storm itself, is at 972 millibars, which is quite low for a extratropical low pressure area. But the biggest thing I wanted to point out to you here is just how tightly packed these isobars are. Now, these brown lines here, these are isobars, lines of constant pressure. And where you see these lines of constant pressure packed tightly together, that indicates a big difference in temperature, or pressure rather, over a short distance. And that's what helps to drive the wind. So it's not necessarily that the low itself was very deep or very strong, and it was, but it's the difference in pressure between this low and the high pressure systems across the eastern Great Lakes and southern sections of Quebec. That's what helped to drive those very strong winds with this particular storm. Here's a different view of that system, again, developing the view from space, infrared satellite imagery. Again, you can see not much going on as the loop initially starts. quite a bit of cloud cover from Florida to the Carolinas, but of course you start to get those darker greens, some oranges and reds indicating some very high altitude cloud cover as that system developed and moved to the northeast here. And again, I'm going to show just a particular snapshot of that system. And what I've outlined here in yellow is the comma head of that system. Now, there's actually a lot of dry air pushing into it just south and east of the actual low pressure area, which again, at this point was still located to the south of Martha's Vineyard at that point, but all that moisture wrapping around over the top of the actual surface low pressure area and then into New England itself. So we'll take a view here from closer down to ground level with the radar imagery, again, showing you the evolution of that snowfall as it moved initially across Nantucket and the Vineyard, and then across the rest of southern New England and then eastern New England, Maine. Out here, we really didn't get much of anything out in Glens Falls, New York. We were just far enough west that we escaped the wrath of this particular system. But notice the period of heavier precipitation indicated by the very dark green and even some yellows here. And I actually put in a brief pause here, right there. And I want to key in on that. So as I advance this, one of the difficulties with forecasting snow totals with storms like this is trying to figure out where the mesoscale banding is going to set up. And if there is mesoscale banding with a particular system, and oftentimes there is when these systems develop comma heads. But where we see these yellows indicated in the radar imagery, that is indicative of snowfall rates of probably 2 to 3 inches per hour. And this band set up from the coast of Maine down across Cape Ann, just to the south of Boston, across Providence and far eastern Long Island. And it sat there for several hours. So if you take, snowfall rates of 2 to 3 inches and you multiply that by 3 to 4 hours of those sort of rates, it's easy to see how you can get significant amounts of snowfall over very small areas. So the difficulty for us as forecasters is, where does that mesoscale band set up? If it's 20 miles farther west, that's where the heavier snowfall totals are. So let's take a look at those snow totals. The jackpot was basically right where I grew up, Quincy and Canton, Mass. I believe there were some reports close to 30 inches out of this particular storm. Even for you folks on the Vineyard, 1.5 feet of snow, not too shabby. But you can see more or less right where that banding set up, an average of 2 feet, Cape Ann, maybe a little bit less there. I do think that there was probably also a little bit of an ocean effect with those strong northeasterlies, probably also tending to enhance the snowfall amounts on the South Shore. But that continued across the Providence area, far eastern sections of Connecticut, and even into far eastern Long Island. That's where the jackpot was with this particular event. So that brings things to a close here. I'll turn things back to John and let me know if you've got any questions.
Anyone wants to ask a question, please type in the chat box and I'll ask one. Brian, can you just briefly describe what it means when they say it's a bomb storm?
Yes, bombogenesis, they like to refer to it. Basically, it's just a rapid deepening of a low pressure area that there is a specific definition for. And basically, it's when a low pressure area that strengthens by at least 24 millibars in 24 hours. I forget exactly what the end result was with that particular blizzard. It was a bomb cyclone. I want to say, though, that it was somewhere around 30 millibars in 24 hours. So pretty significant system for sure.
Okay. There's a question in the chat. Is there always mesoscale banding in a nor'easter?
Short answer is yes, almost always. The heaviest precipitation with nor'easters does tend to occur in the comma head, and those generally do ultimately result in mesoscale banding. Each particular nor'easter is different. Sometimes they'll have one large mesoscale band that could be 20 to 30 nautical miles across. Sometimes they'll have multiple bands across the same sort of width, but the short answer to that question is yes.
Is there a seasonal a component in the sense that something that was a hard blow from the northeast would not be called a nor'easter if it occurred in September or something like that? Or is that, yeah?
Short answer is yes. For example, if it was a tropical system, you can of course get strong northeast winds with let's say a tropical storm or hurricane passing just to the east and southeast of New England. Although typically, fortunately, in those cases, the strongest winds are on the east side of the storms. But as far as the seasonality of nor'easters, they generally are, fall through the spring. They tend to be strongest in the winter time, of course, from December through February and March. And the reason for that is that's when you get those the tightest temperature gradients. There's of course very good examples outside of that particular range. October or April, you can still get strong nor'easters. Of course, during those months, they're more likely to perhaps be more rainmakers than snowmakers, but that's not even necessarily the case. I remember well the April Fool's snowstorm, April 1st. I forget the year. Probably 96 or 97. And we ended up with 30 or 36 inches of snow in Canton, Massachusetts. And it was a heavy, heavy, wet snow. That was a storm that I'll never forget.
There's a question about the more immediate forecast. What about the storm forecast for this Friday? Will that be a nor'easter, and how much snow do you think we'll get?
It's not going to be a nor'easter, but it's still going to produce a fair amount of snow. This time, the roles will be reversed, however. Here in Glens Falls in upstate New York, we're going to get a fair amount of snow, probably around 10 inches. The Vineyard, I'm not 100% on it. It's not going to be a significant snow producer, I don't think, for the Vineyard. You guys are going to be just a little bit too far south for it. You could get a little bit of snow out of it. I think the more significant snowfall for New England is going to be across most of the interior of Massachusetts, southern Vermont, and southern New Hampshire. We need to get that snowfall a little farther north. I'm sure the ski areas would be more welcoming of it.
There's a question about was the storm in the end of October 2021 a nor'easter, where here on the island we had 95 plus mile-an-hour winds at the Chappaquiddick Ferry. What made that storm unusually strong?
I'm trying to remember it. I suspect it was not a tropical cyclone, a tropical system. Was that the one, the winds were strong southerly winds, I think? And I do think that there was quite a bit of damage, not only in the Vineyard, but also through Narragansett Bay up toward Providence.
Well, this one, I can't remember the exact date. I should. I could look it up, but it was from the northeast because a couple of trees fell down on one of our properties.
Yeah.
And so I know very well it came in from the northeast, quite strong.
The short answer, unfortunately, I'm drawing a blank. I can't remember that particular storm.
Yeah,
off the top of my head, unfortunately, at least.
It was a big one here on the island. October 27th, someone's saying in the chat. So
Yeah, I'm sorry.
Okay.
I could look it up, but it would take me a little bit of time to look that up.
Someone's asking, with wind and drifting, how do you measure the amount of snow accurately?
Very good question. That and honestly, it's difficult. Ideally, people would have a snowboard. Basically, it's a flat white board, and ideally, you'd have several of them. But when you get it, especially a storm like that storm at the end of January, when you've got 40, 50 knots of wind resulting in all that blowing and drifting, it can be challenging. You've got to, ideally, you've got a place that's somewhat sheltered from the wind, but you've got to sometimes just use your best judgment is the best way to put that.
Yeah, I think where I was, the snow on the back porch was only maybe about 10 inches or something, but it drifted up to about 15 and I couldn't get the back door open. So
Yeah,
that was sealed me in.
Yeah, I think sometimes too, you can, one way of getting around it is to just take a bunch of measurements and then take an average of those measurements.
Yeah. Okay, I think that's it, unless there's, nope, that's the last question in the chat. So
John, can I ask one question, because I don't want to type this much?
sure.
So in November, when people are heading offshore, heading to Bermuda, and they follow lows, I suspect they're not following nor'easters. But can you comment a little bit on kind of timing and how people decide to, make their timing heading from Martha's Vineyard to Bermuda a little bit, following lows? Yeah,
absolutely. You can follow nor'easters. I mean, the beautiful thing coming out of New England following a nor'easter is the winds are northwesterly. So, it's a following wind, running conditions, but the good news is, of course, as that low pressure area is moving away, of course, the winds are typically diminishing. So you may be better off kind of going south of direct toward Bermuda, with the idea then being that ultimately, typically those lows are followed by high pressure areas, but then the high pressure areas themselves continue off to the east, and you may have another low pressure area develop. So when those northwesterlies back to the west and then the southwest, if anything, you're going to want to be a little west of that direct route to be able to ride those southwesterlies into Bermuda and not have to buck into them, so to speak.
Thank you.
You're welcome.
Okay. Well, thanks, Brian. It's been really interesting. And I'd also thank everyone who gave a donation. We really appreciate it. It helps us to put on these winter lectures, and also helps us to do all the great programming we do, like our summer classes, which you can sign up for now. Don't forget, sign up early. We've already got 200 kids signed up for this summer, and they're coming in rapidly. So if you've been sort of thinking about it, putting it in the back of your mind, it's a good idea to get in a little bit early this year. Things are going to be busy here on the island. Again, I've been recording this. I'm going to put it up on our website under events, winter lectures. It should be up by tomorrow afternoon if you want to review it, or let any of your friends know to take a look. Thanks, Brian, and hope everybody has a good evening, and stay out of the rain, which it's happening here.
Happening here as well. My pleasure. Take care, everyone.
Have a good night.
Thank you. Appreciate it.
Very welcome.
Thank you.